The graph of quadratic function f is shown on the grid, which equation represents the axis of symmetry of the graph of f. Now, in order to do this, we're hoping you did your asynchronous lessons or were paying attention previously, but axis of symmetry. First, ask yourself, what does symmetry mean? Symmetry means to cut something directly in half. So what you're going to do is go to the vertex, which is the midpoint. That's the place where it turns around and goes the other direction. And we want a straight line that goes to that point vertically. What cuts it in half? Okay, so right here. And we can see it goes through x equals -5. So as long as you remember what the definition of symmetry is, where does it cut in half, then you can find the axis of symmetry. Now, let's say, of course, that you aren't given the picture, you're just given the points. So let's say you're given this point and this point. You want to find out what's the halfway point between the two x values. So that's going to be -10/2. And so that's x equals -5. We're going to apply the exponent rules to simplify the expression below. I'm going to go ahead and first multiply these two expressions together. So first of all, we have -1 times -1, or sorry, times -5. Those are my numbers. So we have our -1 and -5. Okay. And then next we have our x's. So we have x squared times x to the -2. Perfect. All right. And then from there, we have y to the -2 times y squared. And then we have, let's go with z. This is z to the first because there's no exponent. And times z to the -1. All right. So let's go ahead and work this out. First part of the problem. -1 times -5 is 5. X squared times x to the -2. Remember, we're multiplying exponents. We add the exponent, or multiplying the bases with the same base, different exponent. We are going to add the exponents. So 2 plus -2 is 0. Okay. Anything to the 0 power is 1. All right. So then we have the same thing with y. We have y to the 0. And we even have z to 0. So given that information, we have 5 times 1 times 1 times 1. And therefore, we have a final answer of 5. Now, if you weren't sure on how to do that, you again could use Desmos. Just remember that when you're using Desmos, you can need to change the variables into not x, y, and z. So let's say a equals 2, b equals 3, and c equals 4. Again, you have to make sure you change all the variables the same. So we're going to have -a b squared c, close parentheses, open parentheses, -5 a raised to the -2 b squared, and c, not z, c raised to the -1. Okay. All right, so we have all of that. All right, so if you enter it all in correctly the first time, which I couldn't figure out what's going on, you'll notice I still get 5. So I actually was missing a couple of variable or exponent properly were entered incorrectly. So if you can spot those, good job. But the answer is 5. Now let's go ahead and do the next one. We have negative 6x squared y times 2x to the negative 3y all over negative 12x to the fourth. I'm just going to keep these as a, b, and c when I put them into my calculator. All right, so one thing I could do is just run this through the calculator using a, b, and c. But let's practice with our exponent rules first. First thing we need to do is we do need to simplify the numerator before we can do anything else. All right, it's grouping. So this is grouping. So this is like parentheses. Okay, so let's do the top. Negative 6 times 2. And then we have x squared times x to the negative 3. And then we have y times y. Okay, so that means I have negative 12 on the top. I have 2 plus negative 3, or yeah, 2 plus negative 3 is negative 1. And then 2 y's gives me y squared. Right? And then the denominator is given to us as negative 12x y to the fourth. Okay, so again, let's break it down. We have negative 12 over negative 12. Negative 12 is positive 1. Okay? And then we have x to the negative 1 over x to the 1. Oops. And then remember, when we were multiplying, we added the exponents. So when we divide, we're going to subtract the exponents. Okay, so negative 1 minus 1 is negative 2. Okay, and then y squared over y to the fourth. Right, and again, that's going to be 2 minus 4, so it's going to be negative 2. Best way to write this is a fraction. Remember, negative exponents go in the denominator. All right. And so again, if we change those to A, B, and or A's and B's, we can see that if we put the original expression into Desmos of negative x a squared b times 2 a to the negative 3b, all divided by negative 12ab to the fourth, we get 0.0277777777778. It doesn't really matter. We can say 1 over 36, right? And then we can test our answer by making sure that what we got matches. So it's not x, a, b squared. And then what I got was the same answer, all right? All right, guys, for this question, a graph of a quadratic function is shown. Which location best represents the negative root of the function? First of all, as a reminder, we want the negative. That means we do not want the positive, so we're going to stay on the left-hand side of the y-axis. And we're looking for roots. Now, as a reminder, we just need to refresh our memory. Root is another word for zeros, our x-intercepts, solution. Okay, we have a graph here, so we're looking for x-intercepts, and we want the negative one. So all we're going to do is look at these two x-intercepts right here. Which one is negative? Well, C is negative. It's on the left-hand side of the y-axis, and that's going to be negative 1, 0. A graph of a quadratic function is shown. Which values best represent the zeros of the function? Okay, so again, we are going to be looking at the x-intercepts. And that is the wrong color of highlighter. So we're here at -3 and 2, right? So this is -3, 0, and this is 2, 0, which means that our zeros are -3 and +2. This one, if you are doing the amplify, it is going to be a matching activity. How many times does each of these graphs cross or touch the x-axis? That's what we're looking for here because we're looking for the number of zeros, right? So this one crosses 1, 2. So this graph has 2 real zeros. This one does not touch. So this has no real zeros. And this one touches once right here. So it has 1 real 0. All right, the equation x times x plus 7 equals 78 can be used to find the width of a rectangular deck that has an area of 78 square feet. What is the width of the deck? A couple of ways we can do this. My preferred strategy would be to graph it though. And to graph it, we can do one of two things. We can say x times x plus 7, and then we can subtract the 78 from both sides and set it equal to 0. Or we can graph this as two separate equations and see where they cross. So if we were to graph this as two separate equations, it would be y equals x times x plus 7 and y equals 78. Okay, so let's do strategy A first. The first strategy, easy enough. X, oops, times x plus 7 minus 78. Okay, and I am going to zoom out a bit. And I'm going to pick 6 because this is the positive root. We can't have a negative width. Also, none of these, I changed it to 13 on the amplify, but none of these answers are the 13. So we can find that that answer is negative, or it's positive 6. Okay. And for the other strategy, y equals x times x plus 7 and y equals 78. What you're going to do is find where they cross, and you can see that this is where they cross here as 678. What is the positive solution to the equation 3x plus 2 quantity squared equals 121? Again, there are several ways to complete this problem, and the simplest way is to graph it. So we're going to do that first. And to graph it, we first need to bring the 121 over, or we can do it like we did the previous problem, where we graph it twice. But I'm going to put 3x plus 2 quantity squared minus 121 is equal to 0 into my calculator. 3x plus 2 squared minus 121. And I'm only looking for the positive solution. So let me go ahead and label that just so it's in the picture. And we're going to get 3. So when you're doing this in Amplify, all you need to do is put 3. You're the ambitious type and you'd like to do it by hand. Of course, you can do that. So we have 3x plus 2 quantity squared is equal to 121. I'm going to undo my exponents first. I need to get rid of it. So I'm going to take the square root of both sides, and that gives me 3x plus 2 is equal to positive or negative 11. So I'm going to do this twice. We have 3x plus 2 is equal to 11. And we have 3x plus 2 is equal to negative 11. So on this one, I'm going to go ahead and subtract 2 from both sides. I'm going to actually do that for both. And we get 3x equals 9. Divide both sides by 3. And we get x equals 3. That's already positive, but let's just make sure. And I get 3x is equal to negative 13. Divide both sides by 3. And x is going to be negative 13 over 3. As those are both prime numbers, I'm not going to go through too much trouble running that through a calculator. Right? But the positive one was 3. Okay, of course, there are multiple strategies for completing this problem. In the expression shown, x is a positive number, and they want to know what the equivalent expression is. So what I would actually do is, personally, I would do the exponent rules by breaking it down into multiple parts, just like I always do. So I have 5 over 20, and that's 1 over 4. And then I have x to the 18th over x to the negative 7. Remember, when we're dividing same base, different exponents, we subtract, and don't lose that negative sign. So I'm going to negative negative is a positive, and that gives me x to the 15. I'm sorry, 25. I can add. And what I'm going to use that for is to help me know which ones to check. Helps me eliminate. But this is the answer I got, 1 over 4 times x to the 25th. And then, of course, we can graph it. So we have, and again, when I have big number or a lot of stuff in the numerator, a lot of stuff in the denominator, what I like to do is make the fraction bar first, and that just makes it to where I can put the numerator in and then the denominator. So we have 5x raised to the 18th over 20x raised to the negative 7. Oops, forgot to down. Okay, and that gives us this funky looking graph. And then we can say 1 over 4, x raised to the 25, and we can see that we're covering the graph. Okay. Sometimes if you're doing square roots, it won't do it properly, but it's always good to know. So we see we can cover these two graphs, and that is the easiest way to do it. Looking here at number 7, what expression is equivalent to 3y squared all raised to the negative 4th over y? And that's going to be similar to question number 7. So again, we can do a couple of different things here. We can apply the exponent rules. We can see that everything's a fraction on our answer choices, right? So what we're going to want to do is let's go ahead and use our exponent rules. So we're going to take this negative 4 and it's going to apply to everything here. So I'm going to take everything and move it to the denominator because it's negative 4. So that is going to be 1 over parentheses 3y squared raised to the 4th times y. Okay, so 3 to the 4th is 81. So that's 3 times 3 times 3 times 3. Y squared to the 4th. Remember, when we have an exponent raised to another exponent, we multiply them. Okay, so that's y to the 8th. And then we're going to multiply in another y, so that's y to the 9th. If you wanted to do it in the calculator, just change all the y's to x's. Okay, so we can again put our fraction bar. We can put 3x squared, close parentheses, exponent negative 4. Okay, and again, I know it looks like it's not an exponent, but it's a little number outside the parentheses. And so that's what causes that. And then again, 1 over 81 x raised to the 9th power. And we can see, again, that the graphs overlap. Okay, so we can see off, on, off. And if that's not your particular brand or cup of tea, remember you can change the variables to A or B or whatever, and then go ahead and do a numerical. So let's say A equals 2. And now I'm going to change my y's to a's. So I'm going to have my parentheses, or sorry, my fraction bar, then parentheses 3a, let me use the math keyboard, squared, close parentheses, and this is bringing another exponent, so negative 4. So I'm hitting the buttons on the math keyboard, and then we have a. And we get 0.0000421, whatever. Doesn't really matter. The answer choice we're going to check because that's the one that we know has the same answer. If we would like to see it in a fraction, we can see it in a fraction.